Hello everyone, now we'll see the exercise problem. I have written the problem here. Determinant, you have to prove this is equal to this one, right? And see here, you can see this. Here x, y, z is there. Here x square, y square, z square is there. And you have to prove this as x minus y, y minus z and z minus x. So what operation we can give here? Clearly it is R2 changes to R2 minus R1, so that I will get here y minus x. Here I will get y square minus x square. Here also zx minus yz. And R3 changes to R3 minus R1. So this will be z minus x, z square minus x square and xy minus yz, right? So we will give that operation. R2 changes to R2 minus R1, or else you can give the operation R1 changes to R1 minus R. That is also possible. This will be x minus y, this is x square minus y square, and this is yz minus zx. Any operations you can give, but final thing is you have to prove this determinant equal to this one. Now I will give the R3 changes to R3 minus R1. Simultaneously we give the operations. So this is now determinant of, first is same, x square and yz. R2 minus R1. So this will be now y minus x, right? So this is now y square minus x square, y square minus x square. Next will be zx minus yz. R3 changes to R3 minus R1. So this will be now z minus x. Next term is z square minus x square, and this is xy minus yz, right? What we can do next? Here y minus x is there. This can be written as y plus x into y minus x. Here also you can take z common, right? So we'll do that one. So this is equal to determinant of x square and yz, and this is now I can write this is as it is y minus x. This can be written as y minus x into y plus x, right? It's of the form a square minus b square. Here we can take z common. If I take z common, remaining with x minus y. Here this is z minus x, and here this is z minus x, similar to that a square minus b square, z minus x into z plus x. Here we can take y common. So if you take y common, it is x minus z. Yes. Here we can take either y minus x common or x minus y, right? Both are possible, but here actually we have to prove this is equal to x minus y. For that reason we will take x minus y. If you take y minus x, finally you have to multiply by the negative sign. Here we will take x minus y common from the second row. This is from the second row, and here what we have to take there, z minus x is there. So we will take z minus x common. So z minus x, this is from the third row. What is remaining here? First is say x square and yz. Here we have x minus y. So here y minus x is there. So this will be now minus 1. So here this is y minus x. So this is now minus of y plus x, right? So this is x minus y is there. So this will be z. Last row we have taken z minus x. Anyway z minus x is there. This is 1, and this is z plus x, and this is x minus z is there. So this will be now minus y. Is it clear? Now the next step, we'll write that what is remaining, x minus y into z minus x, and here you can see this. Here we have to make some element as 0, right? If I give the operation R3 changes to R3 plus R2, so that 1 and minus 1 will get cancelled. It will be equal to 0, right? So directly give the operation R3 changes to R3 plus R2, right? R3 changes to R3 plus R2. So first two rows are same, that is x square, and next is this is y and z, right? And here minus 1, I can write minus y, and this is now minus x, and this is z. And here 1 minus 1 will be equal to 0. So this is z plus x minus y minus x. So x and x will get cancelled, right? So remaining with z minus y. Is it clear? Z minus y. Next here minus y plus z. Minus y plus z. Now you can see this one in the last row. Here z minus y is there. Here also z minus y is there. We can take that common, right? So this is now x minus y into z minus x. We'll take z minus y common. If I take z minus y common, remaining with x, x square and yz. This is minus 1 minus y minus x, and this will be z, and here this is 0 and this is 1 and this is also 1, right? We made one value as 0. We have to make another value, but here it is not possible, right? And one more thing, you can't give the operation like this, C2 minus C1. You have started with the row operation, so throughout the problem you have to give the row operation only. Okay, if you start with the column operation, then column operation only. You are not supposed to switch into the row operation. So here we can't give this, operation here. We can't give C2 minus C3. So next what we can do, just we'll expand this one. We'll expand along the last row, because here 0, 1, 1 is there. It will be easy, right? So now I'll write this one, expand along R3. Expand along R3 last row. This is now x minus 1. This will be now z minus x, and this is z minus 1. As I told you, we are expanding along the last row. Here this will be plus minus plus. This is minus plus minus. So this will be plus and this is, right, this is plus and this will be minus and this is plus. No need to write 0. Next we'll go to the minus 1. So I'll write minus 1 into, delete last row and this column. So this will be now xz, minus into minus will be plus yz. xz plus yz, and here we have to delete along this one, plus 1 into, delete this and last row and this column. So this will be now minus xy minus x square. So this is minus into minus plus x square. So minus x square and plus x square will get cancelled. So this is equal to now x minus y into z minus x into z minus y. So if you multiply by the negative sign, here also minus is there, we'll take that out. So remaining with xz, have taken negative out, xz plus yz plus xy. Is it clear? Minus is there here, minus sign. So here you can see this one, x minus y is there, z minus x is there, here z minus y is there, but we need y minus z. So we'll take minus common here. So here one minus is there, here another minus. So minus into minus will be plus. So we got the proof, right? We got the answer, that is x minus y into z minus x. By interchanging this one, this will be now y minus z. And we have taken the negative sign, here negative is there, right? So the remaining with this xz plus yz plus xy. So this is the proof of this determinant. I hope you understood this one. Here I have written two problems. Both the problems are similar and you have to solve this problem, okay? And this is simple one. You know that this is the first column is 1, 1, 1 is there. What you can give, the operation you have to give, R2 changes to R2 minus R1 and R3 changes to R3 minus R1. Then you expand, you will get this answer. I hope you can do this one. Now only you take one pen and paper and solve this. After that only watch this video. Okay? Yes. Now we'll see this one. Now see here, the first row is 1, 1, 1 is there. Now I have to give the operation along the column, right? If you are not comfortable in the column operation, what you can do? Here you can find the transpose of this matrix. Okay, you know that determinant of A and A transpose will be same. Find the transpose of this one, then apply the row operation. Anyway, or else you can go with the column operation only. Here I will do the column operation. That is, I will do C2 changes to C2 minus C1 and C3 changes to C3 minus C1. Now we will do this one. The column, first column is as it is, that is 1 A and A cube. C2 minus C1. 1 minus 1 will be 0. This is now B minus A, right? So this is now B cube minus A cube. C3 minus C1. 1 minus 1 will be 0. So this is now C minus A, and this will be last term will be C cube minus A cube. Now we will expand this one. To expand this, you should know the A cube minus B cube formula. I hope you know this formula, right? 1, 0 and 0. So this is as it is A, B minus A, and this is C minus A, and this is A cube. What is B cube minus A cube? You know that it is equal to, yes, I hope you know, B minus A into B square plus A square plus AB. This is the formula. Similarly, C cube minus A cube will be C minus A into C square plus A square plus AC. Is it clear? Now you can see here in the second column, here 0 is there, b minus a is common, and in the third column, that this is the third column, c minus a is common. So we'll take that out. So now what is remaining? I'll take b minus a from the second column. So this is now b minus a, and here we'll take c minus a from the third column. What is remaining? In the first row it is say 1a and a cube, 1a and a cube, and second row it is 0, then 1, next will be this is b square plus a square plus ab, and here what is remaining? 0, c minus a we have taken out, 1, and remaining with c square plus a square plus a into c. See here 1 and 1 is there, either you can give the operation c2 changes to c2 minus c1, then you can expand, that is also possible, or else here only you can give the expansion. Anyway, we'll do here only, we'll give the expansion. So this is now b minus a into c minus a. Anyway, in the first row 1 0 0 is there, we'll expand along the first row, 1 into, delete first row and first column. So this is now c square plus a square, right, plus a c, and this will be now minus b square minus a square minus a into b. So which one will get cancelled? Minus a square and plus a square will get cancelled. Remaining with here b minus a into c minus a. So this is now c square minus b square is there, right, plus ac and minus ab. So clear? Plus ac and minus ab. Just arrange this one, c square and minus b square plus ac and minus ab. Now this one again we can write as b minus a into c minus a. Here it's of the form a square minus b square. You can write this one as c minus b into c plus b, right? A plus b into a minus b, plus here I can take a common. What is remaining? C minus b, right? C minus b. Again we can see here c minus b is common, so we'll take that out. So this is b minus a into c minus a. We have taken c minus b out, common. What is remaining here? C plus b plus, this is here remaining c plus b, plus here it is remaining a. Right? We have proved this one, a minus b. Here we have b minus c, so you can take minus common. So this will be now a minus b. And here we have c minus c. Yes, it is correct, right? And here we have c minus b. But we need b minus common. So minus here, one minus is there. And here one minus. So minus into minus will be plus. So this is c minus c. And this will be now b minus c. And last term is a plus b plus c. This is the proof of this determinant.